All right, so last time, this is the section we were working on, 3.1, Statements and Quantifiers, and we had gotten to the point where we had seen a chart that we filled in. This chart is here, and we wrote down some details about some symbols. The symbol not has a tilde. The symbol for and is an upside down V, and the symbol for or is a V. We talked about relating statements with symbols, and we're going to take a look with that idea at a couple of problems. And so what you see listed here is some language that we're going to be represented as symbols. Let be represented as symbols. So they give you the first letter, and this is a P. And they say P is going to represent the statement, she is a teenager. And then there's a letter Q, and the Q is going to represent the statement, he is a lawyer. And so what we're supposed to do is to take these symbols, which is tilde P, this upside whatever, and then a tilde Q, and write down in language what this statement says from symbols. Okay? You with me? All right, so if P is she is a teenager, what is tilde P?
She's not a teenager.
She is not a teenager. And then what about this upside down V? What symbol does that represent? That's the word and. And then we have the symbol that's a tilde and a Q. And so what would tilde Q mean? He is not a lawyer. And just like we want to be able to take the symbols and turn it into language, we also want to be able to take the language and turn it into symbols. So the next slide, that's what we're going to do on that one. Is it okay if I go to the next slide? Okay. All right, so same kind of thing. The P and the Q represent almost the same statement, not exactly, but close. The P here is the statement Leah is a teenager, and the Q is the statement that Joe is a lawyer. So almost the same as the last one, right? Very similar. And what we're going to do instead on this one is we're going to take a statement, Leah is not a teenager or Joe is a lawyer, and we're going to write it in symbols. And so there's three pieces of information here. There's the piece that comes before the connective, and then there's a connective, and then there's a piece that comes after the connective. So the first piece says Leah is not a teenager. How will I represent that in symbols?
The P with that symbol.
Yeah, so the tilde comes in front, okay, and then the P, like this. Yeah, so the tilde will come before the symbol, and then P is representing the statement that Leah is a teenager. We need to negate that because it says she's not. How do I get the word or in symbols?
V.
It's a V, that's right. So we put the V up there. And then the last statement says Joe is a lawyer, and what symbol represents that? Q. Now, this stuff is not terribly challenging. I mean, you're just going back and forth between words and symbols. It's kind of like when you were really little and they said A is the number 5, and so every time you saw 5, you wrote the A down. It's kind of like that, okay? But we're going to build upon this, and we're going to be using this as we continue in this section, so it's a good place to start because we have to have this foundation, okay? All right, a couple other things in this section then is we're going to take a look at these items involving quantifiers and to decide if they are true or false. And this goes back a little bit into what we did in the last chapter where we talked about our number systems, rational and irrational. And actually, I'm going to show you, I'm going to show you one thing out online when we're done with this if I can find it, okay? But, all right, this says first, to decide whether the statement involving the quantifier. Okay, we talked about quantifiers last time. What were the two types of quantifiers? Mason's looking for us. What are they, Mason? Can you find them? I know, but you've got the paper right there. Universal and existential. Very good. Thank you, Alexis. So what were universal quantifiers? What kind of words did we use when those were going on? All, none, never, right? Statements that applied to everybody or nobody, right? Okay. And then existential quantifiers used what kind of language? Some. Not all. All is universal. What else besides some? Besides some?
There exists.
There exists. There's one more. For at least one. Those were the three we'll see the most. The if and the then are connectives, and we're going to use those, but they aren't quantifiers. Okay? So existential quantifiers is simply telling us that something exists, right? And it happens for some things, maybe not for all. All right, so these statements right here each have universal quantifiers in it. So just so that we were on the same page, number 9, what's the universal quantifier? What do you see? All, and it's universal, right? What's the quantifier down here in 10? Each, which means all as well, right? It means all, okay? All right, so this says all irrational numbers are real numbers, and we need to make this statement of whether that's true or false. So what do you think? If you say false, you have to give me an example of an irrational number that is not real. Tyler's opting for true, so he doesn't have to give me an example. I can tell. It is a true statement. Do you guys remember the rectangle diagram we did way back when? And it looked something like this. Do we remember this diagram? I'm not filling in the details of it, but the big outside rectangle was real numbers. Everything inside of it was types of real numbers. And one of these blocks, it was actually this one, was the irrational ones. So it's a part of the bigger box. Irrational numbers are real numbers. Okay? So this is a true statement. All right, so number 10, again, the word each or the word all is used interchangeably here. All whole numbers or each whole number is a positive whole number. Hmm?
False.
Why do you think it's false, Mason?
Because there's extra room on a page to write something down.
Well, it is false. And you know what I would tell you is false? Because I tend to usually give you one example where they're true and one example where they're false, don't I? Have you noticed this? It's sort of a drawback. I do that. Yeah. It is false. But Mackenzie, you were trying to tell me that you thought maybe it was true. Can you tell me what whole numbers are? Do you remember what they are?
Like positive, well, I don't know.
Okay, so can somebody give me one example of a whole number?
0.
1. And Cheyenne, you're telling me 0. Why does 0 matter? It's the counter example, right? It's the one that doesn't fit in with this description. So the whole numbers are the counting numbers, 1, 2, 3, 4, and so on, but they also include the number 0. And 0 is exactly the one here that fails. Right? 0 is not positive. It's not negative either, but it's not positive. So all whole numbers are not positive. The number 0 is not positive. And that would be an example. It doesn't ask you for an example on this, but if you can't create an example, that starts to lead you to think something's true. So anytime you're looking at these kinds of questions, you need to ask yourself, if it's false, why? What number am I thinking of? And if I can't find any number that fits the description backwards or that doesn't fit the description, then I might be led to think something's true. Does that make sense? You got to be figuring out at the same time whether or not you can come up with an example or whether there are no examples. All right.